Welcome to RACSINFOTECH. In this video, I'm going to start the Oracle Exadata related knowledge, guys. Now, I'm going to share Oracle Exadata related knowledge. So, Oracle Exadata on-prem, we can able to do it this on-premises service, and Oracle Exadata DBCS is one service, ExaCS is another service, ExaCC. So these are all the things where Oracle Exadata software engineered system where we are going to use and working for our organizations. Okay. So what I'm planning is I'm planning for around 20 sessions on Oracle Exadata related things. Next couple of days, I'm going to upload all this information. It may take a month or it may take more than a month, but I'm planning to complete all these modules are number of days, the topics which I'm going to share in my YouTube channel. So today topic is this one, day 0. You can see the on YouTube video. Day 0, we are going to look about Oracle Exadata key features and some monitoring tools. How we are going to our monitoring tools, or you can say utilities. Okay, commands, whatever it is, tools, commands, or what I can say, commands are fine. How we are going to use the tools, what types of the tools which you are using in Exadata. Okay, as an Exadata engineer or Exadata database administrator, Exadata administrator, what are the things we should aware of it. Before going to in depth of this topic, today topic, let me explain high level of background about this Oracle Exadata. So Exadata, you should aware if Exadata we can manage in on-prem services, and Exadata we can able to handle in these three ways. These three are in cloud. Okay, Oracle Cloud. If you want to manage Oracle Cloud infrastructure, and the DBCS means database cloud services, database as a service, and database cloud services. In this part also we can use Exadata, Exadata cloud services, ExaCS cloud services, and Exadata and cloud at customer. Okay, cloud at customer. This at we can make like this, cloud at customer. So all these ways we can different types. How we are going to handle your Exadata services and ExaCS. How we are going to handle these Exadata machines and cloud at customer. How you are going to manage your Exadata servers and DBCS, and how you are going to manage your Exadata software or the boxes or Exadata services on-prem. So different things will be the way we are going to work. Most of the environments, the same commands, those commands we are going to learn today. And yeah, the way we are going to work on cloud at customer and cloud services or database. I'll try to make it couple of different videos. One video related to this and one video related to the Exa cloud services and Exa cloud at customer. So all these things I can try to plan it. But in this video, you're going to learn about these things. Oracle Exadata key features and some monitoring tools or commands in Exadata high level things. Okay. What about this Exadata? What is the latest version in Exadata which is released from the Oracle X11M? It's the latest version. Okay. Before a few couple of customers, they are in X7 and X8, X9, X10 also they are using. So latest is X11M. That's where I mentioned this thing. So X11M, M means what do you mean by this M and other things we can discuss later. And yeah, let me explain introduction, just a bit introduction. We do have a separate session where I can explain in depth of Exadata related things, why we need to use Exadata, what is the difference compared to our traditional environments and Exadata. So in Exadata, this kind of servers we used to purchase, like the customers is going to purchase Sun Oracle, right? Both is Oracle only. Sun has been acquired, like Sun Systems acquired by the Oracle. Oracle now owns by this. So this is completely box, Exadata box. It looks like this. Okay. Here used to have, these are all storage servers. These different servers, right? These are all the DB servers. These are all DB. And these are storage or cells, we call it as. This is InfiniBand switches. InfiniBand switches. Again, here we have these four are belongings to DB database servers. Another thing we call it as a compartment, not the compute node. Compute services or DB servers are same. Okay, this is 4 compute servers on top of your InfiniBand switches. 4 compute or database servers below your InfiniBand switches. And then next, these things are again storage or cell services. So here you can see it around 7, and here storage cells are 7. If you are going with this 4 dB here and 4 dB here, these InfiniBand switches are 2 for high availability. Okay. By using these InfiniBand switches, database server and storage cells or storage servers will communicate each other. All together, everything is in single box. So they are going to also they are dedicatedly design the software for cell software separately in Exadata. Database server software, they are intelligent software they have defined in storage level and the database level. Okay, two different levels. This is the high level, guys. And how many types of cloud, like if you can go with cloud Exadata, if you want to purchase an Exadata servers like 8th rack EIGHT, 8th RACK, 8th rack is the startup Exadata software. If you want to Exadata box which you want to buy, and then quarter rack, then half rack, full rack. These are all the types. And even in storage level also we have different. We will talk about that later. Okay. Then performance related and cache related storages will be the 8th rack. It will 8th and quarter rack will come with 2 dB servers. Here we have 4, right? But if you took 8th rack or quarter rack, you will get only 1 dB here and 1 dB here. And storage cells, you will get 3. 2, 1 or 2, 1 likewise. Only in this box, entire box, you will get only these things. Then what is the difference between 8th rack and quarter rack? Suppose this quarter rack is supporting 200 terabyte. Okay. Of even in the memory level and the storage level, everything. So half of the memory, half of the storage, they are going to reduce on this 8th rack. Okay. Suppose you are going to use 200 terabytes of storage. In 8th rack, you will get 100 terabytes only maximum. Here, if you'll get 100 terabytes of memory or CPU things, here you will get 50 terabytes. I'm giving an example, guys. So what is the difference between, so half, even though the structure minimum, these should be there. 2 dB servers or compute nodes, 3 storage servers should be there if you want to purchase an Exadata. But if you want to go with 8th rack, that is the costless, and also resources also half of the resource compared to your quarter rack. Here you will get huge amount of full memory and other resources. Coming to half rack, you will get 4 dB total in the rack, 2 here, 2 here. 4 database nodes, 4 dB nodes or dB services are computes, 6 storage or cell servers for half. Full rack, 8 dB servers or compute nodes, 12 cell servers used to get, or 14. Okay, by default you have this structure, but 14 we can able to add it. Even we can extend more also in this different, but 8 dB servers are compute servers, 12 storage servers. Okay, this is the difference, guys. 8th rack, quarter rack, half rack, and full rack. So now why we are going to use it, right? Both the servers and storage, database servers and storage servers provided with Oracle, and avoid the compatibilities and other network or other things. So we can achieve half of the performance from here itself. Okay. Earlier we used to use database servers from HP, storage servers you can use different NetApp or HP or Oracle or some other IBM. So different combinations we used to use in our regular or traditional environments. But in Exadata, everything is managed and configured from the Oracle side, and it is a specially designed software, specially designed machine. Okay, fully integrated platform for Oracle databases, Exadata. We are going to use it. And also this Exadata we can use for high availability, performance improvements, all the database workloads like OLTP and OLAP, both types of databases we can able to, this Exadata is going to support. Hardware and the scale out architecture, it is going to balance, and it well suited for cloud and data consolidation platforms, merge multiple database servers using your IRAM. input output resource manager. It's one of the feature. We will discuss that separately. And simple and fast implementation, like pre-installation with Oracle Linux operating system on this box. This box will come with you with the whatever the what type of Exadata you purchased. It's a eighth rack, quarter rack, or half rack, or full rack. By default, it will come with your Oracle Linux operating system, this box. Okay, that is a high level, guys. So now we are going with today's session, day 0. So Exadata is an Oracle engineered system optimized for running Oracle database and high performance, scalable and reliability. So I'm going to explain in detail of the features. Okay. Majority of the features we are not going to discuss in detail, right? Even though if I want to elaborate and share it comes like 50 pages or 100 pages of these things, more than that. So I'm going to give you high level features, key features. That's where I mentioned key features. Hardware architecture, hardware level. As I said, we have a database servers. We call it as a compute nodes running on our databases. Storage servers, another name we call it as a cell servers. There we have a smart storage optimized for database workloads. On storage server only, we have this smart cache, smart storage, everything smart scan, everything will there in our storage servers. It's intelligent storage. It's not normal storage. Okay. And the InfiniBand fabric connection with a speed of 40 gigabits per second and 100 gigabits per second. This much of huge network bandwidth in between these database servers and the storage servers. Also, we have another feature in hardware level. This is remote direct memory access, RDMA feature. It will improve the directly connecting to your storage and executing the query. I'll try to explain in another video some other specific time I can take in 5 to 10 minutes talk about this, how this is going to work out. This is the high level hardware architecture. This is a feature, another feature in hardware level. Okay. What is mean by the smart storage features? Okay. In storage level, we have a smart storage. We call it as Exadata storage is a smart storage. How it is going to work as a smart? There is a couple of features. Okay. It's a high level. Smart scan is there. Smart flash cache is there. HCC is there. Storage indexes is there. By using all these features, this Exadata cell servers become smart. Okay, how it is going to? Smart scan is going to take care of your SQL processing. Any query which is taking full table scan, the smart scan will invoke automatically, and then it is going to provide whatever the required information that will share it to your database server. Simply in our traditional databases, okay, if you are talking about the rack, we have two node instances, node 1 and node 2. We have shared storage, right? Shared storage, ASM, I can say. If I want to, some user try to access the data, right? 100 GB data, like 100 GB data out of 1 TB table space. This is my table space. User required only 100 GB. Our table space, entire table space is 1 terabyte. Okay. In this, the user needs to fetch only 100, user required only 100 GB. In our traditional, what will happen? User session goes to node 1. From node 1, the memory process, like server process will take care and it is going to, okay, internal communication. Even here also we require the storage communication, right? Here also we have a network, okay? It's different network. We'll talk about later that thing. And once the user query goes to here, it is going to read complete 1 terabyte of this data and it will send 1 terabyte information to your database memory. From here, it is going to fetch related information of 100 GB. This 100 GB is going to give us back to user. Everything load where it is going to happen on database memory, on database server level, instance level, right? This much of 1 TB required only 100 GB, but entire 1 TB is reading from disk to memory. From memory, it is going to separate 100 GB and this 100 GB is going to user. So fetching the data from here to here, one load. If the network speed is less, generally it is less speed compared to this our in this speed. It will be there 10 gigabytes per second, something like that. Okay, that speed is not much in our not traditional environment, and in that case, it may take hours, 2, 3 hours, 5 hours, 6 hours. That's where we are getting these issues, right? Every time on long running. My query day before yesterday, it took 2 hours. Now today it's 4 hours, something like that, right? So everything is database memory level is happening, IO. Okay, everything resource utilization. But in case of our Exadata, what is going to happen, right? We have our database services, we have our storage. In between, we have InfiniBand switches. It is a very high speed network. High speed network. This is 40 gigabytes now. Latest 100 gigabytes. If you are going with this, 100 gigabits per second, it is going to transfer, and the user is connected to this database server. This is going to communicate, the database memory part is going to communicate with your storage. From the storage, whatever the user required, 100 GB, right? There is no index. Okay, if index is there, here also it is going to get it related information, right? And somewhat index is going to fetch that information and put it here, reducing the load. Okay, that is there. I'm not talking about the index without indexes. Even the smart scan will work for full table scan, not for index level. Even if you have in Exadata indexes is there, it will not switch in. If index is not working, it will switch. It will commit and it will take it ownership of that query. Okay, that is separate part. Okay, now what will happen? In Exadata, this is an Exadata, right? Users asked same information. 1 terabyte is there in our storage cells, it's stored. It required only 100 GB. What our storage, a smart scan will do, it will read everything here itself. IO is going to happen in our storage level. And whatever the required blocks, this 100 GB is transferred to database memory. From database memory, it is going to transfer. So there is no load on this database memory. Only sending this 100 GB information. I'm giving an example. Okay, if required only 1 GB from 1 TB, right? Only required blocks is sending back from storage or cell servers to database server, that to high speed network using InfiniBand. That's where the smart scan is pitching only for full table scan. If the query is going through full table scan, smart scan will invoke. Then smart flash cache. This will use flash storage for catching frequently accessed data. Whatever the data we are going to use frequently, that will there in our database buffer cache, right? In traditional. Same way we have our flash cache, smart flash cache in our storage cells level. That will bit quicker compared to your normal data IOs reading disks data from the disks. It is sending from the cache from the storage cells level. It is bit faster than this. And HCC, another feature, hybrid columnar compression, optimizing the storage by compressing the columnar data. Whatever the data is going to write, duplicate, n number of redundancies will be there in column level data. This high columnar compression is going to take the storage what I can say, compressing column level data, and it is going to store and save more than 10x. Like if you have 1 TB data, 1 TB data, you are going to write it in a table. So lot of column level data is going to duplicate. That duplicates is going to have specific header, and it is going to write what will happen. You suppose employee ID. Employee ID, we are going to use it n number of rows, right? This employee ID, it is going to take it one, it is going to assign one symbol like dollar symbol, suppose. This symbol is going to hold it here, and the combination of employee ID, if it is going to n number of times, recursively, that will compress it here. That too, it is going to compress it. The data, 1 TB data, it is going to compress to 100 GB or 10 GB. That much of improvement will be there if you are using HCC. We'll see it in future. If I could able to make it some examples on hybrid columnar compression, it will be much better understanding, like how the smart scan you can able to understand. We can do it another session where HCC can. Okay. Then storage indexes, reducing the IO by maintaining the metadata about the storage. In storage level, automatic indexing feature, okay, it is going to create it. We need to enable, and then we can use this storage indexes automatic. If the query doesn't have an indexes, it is going to create it, and reducing the IO by maintaining metadata. Okay, and other thing, high availability and scalability when you are using RDMA, one of the hardware right feature, fabric interconnect, ultra fast data transfer between nodes. This we can use. ASM, even in our Exadata, we can use ASM for redundancies. Fast fault recovery things. Reduce the downtime with automatic failovers. We can use this option. Okay. And for security and management things, this is another feature which is there in Exadata. Exadata security. Use our advanced security features, TDE enable. Okay. Other things we can use. And the cloud ready services, cloud at customer and Exadata cloud services. These two are cloud ready services. Okay. for security and the thing. And these are the tools, monitoring tools where we can use it. I'll give you some examples today. Exacheck when we are going to use, okay, on database side and cell side, especially if you want to check the cells from the database server and storage server, exacli command line utility, and cell specific information, cell CLI, and the database command line interface, DBCLI. All these are monitoring and maintaining your Exadata administration tasks. By using these commands, we can able to handle it. If you want to check health check of the Exadata database server or compute unit database server or your storage cells, you can use exacheck -a command. Here also you can use DCLI, okay, DCLI-G cell group and -L root name. We can provide the inputs. DCLI, where you can use exacheck -a, it is going to check with cell group, which cell you want to check, that you can able to see it. Or else if you want to check all the cell groups, give this command DCLI-G cell group, runs all the commands in all storage cells. And managing the storage cells with the cell CLI, you can use cell CLI is the like a prompt where you can use cell CLI and it will connect to cell CLI prompt. There you can use list cell details. You will get the cell server status active, or it is up or down, or it is responding or not. Storage disks list, how many disks you are having in each cell. Grid disks, if you are using ASM related things, right? You can check. And ASM disk groups, including the power balance, rebalancing power string, how much it is, 1, 0, 1, 2, 10, something you can mention. And if you want to check flash cache all flush, if you want to clear the the flash cache, we can do this. New grid, if you want to create, use this. Create grid disk, all size equal to how much size you want, you can create it. And if you want to manage the DBCLI database services, use DBCLI. DBCLI list of all the database servers. It will give you entire all the database nodes. If you are having 2 node or 4 node or 8 node, it will show you the complete database related things. ExaCLI, it used for remote execution on Exadata storage level. If you want to check the list of the store, even cell CLI we can use, or you can use ExaCLI commands to check the cell status using different options. If you want to apply the patches using ExaCLI, and then use the patch manager is the tool where you can apply the patches and give the patch ID which you want to apply on storage cells. Okay. If you want to run exacheck, you can go to that Exadata compute node and run dot execution mode exacheck-a and analyze the report, all the compute node, database servers health and other things. Monitoring the storage, you can use these commands. Yeah, that's all about this session, guys. If it is useful, make a comment. If you need more on this part, make a comment so that I can check, and then next video I can able to answer your questions. Okay. So as I said, it's a day 0. We can go with the day 1 to day 20 or 20, maximum 20 sessions. You can finish complete Exadata, but it is not on regular basis. Hope this will help. If it is helpful, like and subscribe my channel, RACSINFOTECH YouTube channel. If it is useful, you can subscribe. Okay. Thank you.